sound. I forgot to check. What do you think the absolute minimum on this one is? What's that? 0, 1. You know, normally we'd be looking for a value, but this point exists, right? That's the absolute minimum. Happens at x equals 0. Value 1. If you ever answer any questions on this, they'll typically talk about what is value, where is the point. Value is referenced to y. So they're pretty simple. We can do the next couple verbally right here. What's this one's absolute max? 3. The absolute max is 3. Where does it happen? At 5, at x equals 5. What's the absolute minimum? 1. Is there anything at 1? No. Big old giant hole in the graph. There is no absolute minimum on this graph. We say it approaches 1, but it doesn't actually exist. There's no bottom of this thing. It doesn't have one. There's a hole there, kids. You may not see it on your notes, but if you look up at the board, don't you see a big white hole there? There is no absolute minimum on this graph. The point has to exist for there to be a value. All right. Does this one have an absolute max? Yay, nay, IDK. Yes. Yes, what is it? Value is 4. X is 5. Ignore that again. Absolute max. Value is 4. Happens at x equals 5. Does it have an absolute minimum? Kind of an interesting question. Does it have an absolute minimum? It does. There is a low y value. What is the low y value? What is it? 1. Yeah. Value is 1. Where does it happen at? Come on, kids, use intervals. It happens over a range, doesn't it? What's the range where this value is achieved? What's the left x value? What's the right x value? 2. So it happens, I'll write it on words, from x equals 1 to x equals 2. But write that out as an interval. What's that look like as an interval? Use brackets or parentheses. Brackets. Those are equal signs. What goes in those brackets? 1, comma 2. That value or y is 1 exists over that interval. Come on, kids, you guys got to get interval notation down. It's not that bad. It's not that bad. Would you just rather write everything out in words? I guess so. All right, how about this one? Does it have an absolute max? Crickets. No. I guess you could say infinity, but you don't even know where that happens at, do you? There's no absolute maximum. The graph goes up to the right forever and ever. There's no absolute maximum. Absolute means it's a point that you can touch and hold on to. You can't touch infinity. Does it have an absolute minimum? What is the absolute minimum? 0. Where does it happen? 0. Okay. When we ask the question about what the absolute max and absolute minimums are, we're asking about the value of y. You guys get that finally? That's what we're asking about. Values of y. All right, how about this one? Does it have an absolute max? Any absolute maximums? Nope. Thing shoots off to infinity. Any absolute minimums? Nope, there's a hole there. All right, here's the next part of our little lesson here. Use a graphing utility to approximate local maxima and minima and to determine where a function is increasing or decreasing. So we're asked to use a graphing utility to graph 2x cubed minus 3x plus 1 for x is trapped between negative 2 and 2. And you'll also commonly see that people will tell you to do it like this. They'll give you a left x value and a right value using interval form. So it says use a graphing utility, so what should you have? A graphing utility. Loves a passion today. Oh, I'm feeding off of it. I need more energy drinks. I'll never get another drink. Y'all get that together. And notice it talks about where x is negative 2 to 2. What do you set that at? Window, maybe?
That's giving you x value. That's a plus 12. It's giving you x. And then everyone will say something. It's trying to tell you that x is between.
No, acting like you forgot where y equals is. Everybody knows where y equals is, right? Oops. Yeah, I caught it. But I have not caught it before. I watched a kid take their EOC about 4 years ago, and it was like the second time in their life they'd ever picked up a TI-84 after a year of algebra 2. And they put everything in the exponential space. He paid attention all year long and knew you could solve about anything with a graph. But he never actually picked up a calculator to do it. And every equation he typed in there, he did like I was doing. Daniel saw what I was doing. He just put everything up there in the exponential space and wondered why he couldn't figure anything out. All right, now I'm going to do a zoom 6. And that's not what the question actually wants me to look at. Do a zoom 6 because it restores your window to whatever it needs to be, 10 by 10. But you were taught that. Always do a zoom 6. This is too much of the graph. Now, it's not a big deal on this problem, but it might be on a different problem. What x values are they concerned about? Yeah, what they're doing here with this inequality that they give us, I wonder if I can drag a piece of it down. No, I can't. I can talk about this though. This notation is telling us to set x min to -2 and x max to +2. That way we only see the part of the window they want us to see. Now you guys have played with window in the past. So I'm going to go to window, I'm going to set x min to -2 and I'm going to set x max to +2. That way I only see the part of the graph that they're interested in. It's not a problem on this one, but if they gave us something with a whole bunch of curves and we weren't paying attention, we might be giving answers that weren't required. Just extra work. So after you adjust your window to have an x min of -2 and x max +2, you can hit the graph button. And you'll get a better picture, obviously. You restricted it. All right, so what are we supposed to do? Find local max and local min, right? I got my little cursor right here. Is that a max or a min? It's a max, right? You guys remember how to find a maximum on a calculator? What's that, Bryce? Second trace. Yeah, we're going to do second trace. Second trace maximum. And what we're going to do is we're going to plot a left bound, press enter, plot a right bound, press enter. We're going to enter for a guess. You probably remember that. Just depends on how often you use your calculator. A lot of times your hands remember things that your brain doesn't. All right, so second trace, that is a maximum, what I was pointing at. And when I do a second trace max, the calculator says give me a left boundary. So you take your little cursor and you get left. Remember doing that? What's wrong over there? Okay. So I got left. Once you get left, you press enter. Now what's it want? To get right. And that means you get to the right of where you think the maximum is. And then you press enter. And you press enter for a guess. Everybody should be getting that we have a local max of about 2.41. If you've got anything different, something is wrong. You should have that. Every one of you should have that as a local max, about 2.41. Where did it happen? Negative 0.71, maybe? I'm just going to screenshot that for the notes. I'm not actually going to write it down. You can do that, but I can. Now that valley to the right, what does it represent? Local min. While you were at second trace, did you see something that might do that for you? What'd you see there? Minimum. That's what it is. It works exactly the same. You get left. You don't even have to be that close. You just have to be to the left, and you press enter. I am a little curious if you shouldn't be under the x-axis. I'm going to get this guy under the x-axis just to be on the safe side. And then you get right. And then you press enter. I've noticed sometimes that when equations are really close to the x-axis, if you don't have your cursor on the right side, like where that thing happens, it'll do some funky things. You might see like a no sign change. There we go. Now, anybody got any issues using a TI-84? What's wrong? Not about the origin, it's about the actual mass or min. We also have an issue with the TI-84. Please stay off your phones. For the love of God, stay off those things. It's really about time we start taking those things up. I keep saying that. I guess I just need to start doing it. All right. Here is average rate of change for a function. Of course, you guys know what average rate of change is. Anyways, there's some funky notation here. This delta y and delta x, you know what delta means? It's a Greek letter. It means change in mathematics. It says the average rate of change is the change in y over the change in x. Well, what is that? Change in y over change of x is slope, kids. Now, as you move up, they start using funkier formulas for slope. Let's talk about here. We have the average rate of change from A to B. Well, that's saying from x1 to x2. That's all that's saying, from x1 to x2, is f of b minus f of a over b minus a. Now, b and a are x values. If you plug x values into a function, what do you get back? If you plug x values into a function, what's it return? Y values. All this is saying is y minus y sitting over what? A and B are x values, kids. X minus x. It's just another way. It's a function form for slope. That's all it is. It's the function version of slope. So don't be intimidated by it. You don't even have to use that formula. If you know it's slope, that's what you use. What's the formula for slope? What's the formula for slope that you've been learning since 7th freaking grade? There we go. y2 minus y1 sitting over x2 minus x1. Are you all fried this morning? I don't know what's up with y'all. That's the formula for slope. It's always been. And this is the same thing. It's just in function notation. And we're doing average rate of change here. If you see average rate of change, it's slope.
Every one of you took me, every one of you had a formula quiz. I didn't call it slope on that formula quiz. What did I call it? I called it average rate of change. All right, so find the average rate of change for this function f of x equals 3x squared. And don't even worry about this thing right here. Gone. From 1 to 3.
Those 1 and 3, what do they represent to you? X values is x equals 1 to x equals 3. If you have an x value, what can you get? You can get a y value. The simplest plugging it in. So if I let x1 be 1, y1 happens when I plug into this thing. 3 times the 1 squared. What do I get? 3. If I let this guy be x2, y2 happens when I plug in a 3. 3 times 3 squared. What's that return? What's that? So you have a set of x values and a set of y values. Can you find average rate of change? Yes. How? By using the formula for slope. I don't know if it's me or y'all anymore. I really don't. y2 minus y1, 27 minus 3, sitting over 3 minus 1. That's 24 over 2. That's the average rate of change on that interval. Well, what that's saying is the line that connects those two things has a slope of what? 12. Now, you need to see me do another slope example. I hope not. I really don't want to. Now, that line that connected those 2 points is kind of special. This is a line that connects 2 points. Lines go on forever, right? And passes through the graph. You guys had Coach Snow for geometry, but in geometry, you learn the name of a line that touches something twice. Called a secant line, which is probably on the next slide. Called a secant line. So the next slide is probably about writing equations of secant lines. Would be my guess.
And this, the class is titled pre-calc. This is the pre in pre-calc here. You don't know that because you haven't had calculus, but calculus is nothing but slope, applications of slope. Over and over and over all day long. So here's the secant line. MSEC. What do you think that stands for? Slope of the secant line. Is this funky little formula? But that funky little formula is just a formula for what? Slope, okay? All right. So we're going to find the equation of a secant line. I've only graded a handful of y'all's tests that you turned in, but why don't y'all like point slope formula? It just baffles me the number of you guys that came up with equations of lines by plotting freaking points. Why? Why are you doing stuff like that? You're supposed to be the cream of Dresden's crop, and you're coming up with equations of lines by plotting points, kids. We're not going to plot points. It's not going to happen. So we have a function called g. It's a negative 2x squared plus 4x minus 3. And a says find the average rate of change from negative 2 to 1. Well, that gives us two x values. We have an x1 value of negative 2. We have an x2 value of 1. That all comes from what they tell us in text. So how are we going to find our y1 value? We're going to plug it in. I'll write that down up here. This is exactly how I type it in a TI-84. Wouldn't do anything special with it. Oh, what's that going to give us? Negative 19? Yeah, that seems right. I also have an x2 value of 1. How do I get the y2 value? Plug it in. I'm not gonna write that out. 4 times 1 is 4. Take away 3 is 1. Minus 2. I think it's negative 1. Now, can you find the slope? So figure out the slope for me. What'd you guys come up with? 6 is right. That's slope of 6. Now we're supposed, and don't be intimidated by their instruction set. I mean, they're trying to use function notation with you. But it says find the equation secant line containing the point negative 2, g of negative 2. Well, did you not find g of negative 2? Did you not plug a negative 2 into the equation? Okay. And 1 g of 1. Did you not find g of 1? You did. So don't be confused by what they're saying. Just focus on the beginning. Find an equation of the secant line. Well, you have slope and you have points, right? What form do you get to use? You get to use point slope form. So part B, we're going to use point slope form. What is point slope form? Yeah. Which points do you want to use? Do you want to use 1, negative 1 or negative 2, negative 19? Yeah, I would use 1, negative 1. That's what I would use. Don't leave it like this. I should have been more clear on the instructions on your take-home test. But when you're answering a question, 99 out of 100 times, you're going to do y equals mx plus b unless you're told otherwise. I didn't dock off for it on that test, but I thought about it. So clean it up. So you have a y plus a 1 equal to 6x minus a 6. You're going to take away 1. What are you going to get? That's 7. Now, they do want us to use the graphing utility to draw the graph of g and its secant line, just so you can see it. Wouldn't kill you. It'd help reinforce the definition of a secant line. Secant line is supposed to touch this graph how many times? Twice. Do a zoom 6, kids. Your window you just played with was negative 2 to 2. You're not going to see the whole picture. Although it probably won't be too bad. We'll do a zoom 6. And everything's right. We're going to touch it twice. Of course, your window only shows once, doesn't it? Where's that second intersection happening? Somewhere down below. I think I'll adjust the Y min to be something like -50. Probably see it then. May have to go farther than that. Nah, it was plenty. Did hit it twice like it's supposed to. All right, any issues with that? Other than just knowing your forms. I guess I really need to restart formula quizzes. I just don't like doing that in pre-calc. Of course, I do it in calculus. Anyways, you need a homework assignment, don't you? Well, I have just a thing for you somewhere. Real question is where'd I put it? I'll go to the next class as a class that you like, enjoy, full of energy. Oh, no, you don't like that class. Yeah, some of the kids in that class have a hard time accepting the person who is different. I think in this case, it's liberal mindset. I mean, every teacher you have in high school cannot be a raging Republican. It's just cool. You gotta have a little fun. Some people don't like that. Allison, please bring me that testimony. And please be working on your projects, kids. The 11th, which is a Monday, I'll help you on that with that day. If there's something that anybody got anything you'd like me to try to draw and I can make a video of, anything in particular, like a shape that you just don't understand how to make, something that you want in yours, maybe you'd like me to draw it and put it on Desmos how to do it. Oh, keep it PG, by the way. Huh?
Did you have problems with the navigator?
Well, 5 years ago, a group I had would have drawn a bunch of naked women. Actually, not even 5 years ago, 3 years ago. A group that had Dylan and Bradley, and there would have been some boobs drawn.